Okay, so this is actually problem number 3 for the homework. So let's go ahead and notate that. So we are on problem number 3. And so what information are they giving us? Well, we know that there is some sort of conditional probability because I see the word given that. That means we need conditional probability. That means the probability of one event happening given that some other event has already happened. Okay, so the next question is, which way do we write the conditional probability? Do we write it as probability of event B given that A has happened? Or do we write it as probability of event A given that B has happened? And the answer is, we want to look for the event that's after the conditioning bar. So when it says given that, whatever's after the word given that is the event that's after the conditioning bar. So this is called the conditioning bar, or the conditional. Okay, that's the so-called conditioning bar. That's telling whatever's after the conditioning bar is what's already happened. This has already occurred. Okay, already happened. All right, so now, is that what's true here? Is it saying that, so they're asking for the probability that he makes his second goal given that he made his first goal. So which one is, so whatever is the first goal, made his first goal, has to be after the conditioning bar. Okay? Whatever's after the word given that. Okay, so now first goal is what? First goal is A, that he's successful on his first goal. So that means A is the quantity or event that we want after the conditioning bar. So that means even though probability of A given B we can ask about it, like we can think about it, that's not what they're asking for in the problem. In the problem, they want to know probability of B given A, because they want the probability of B given that A has already happened. So this is the first goal has been made, or has happened, has occurred. Okay, so that's already happened. This is the one they're giving me information about. They're telling me that this is 0.80. Okay, so even though we could think about A given B, they're not asking about it. They're asking about B given A. All right, so that's the first thing to think about, is which conditional is being asked about. Now, let's write the conditional probability formula. Conditional probability formula says probability of one event given that another has occurred is equal to the probability that both will occur at the same time. And we can write both as either A and B or B and A. It doesn't matter which direction you write it in for an and. Okay? Then what? Divided by the probability that the event that's already occurred, the conditioning event, okay, the one that's already occurred, that's called the conditioning event. The one that's after the conditional bar, that's the conditioning event, has already happened. Okay, so that means the probability of A in this case. Now, what information do we have? They're giving me P of B given A, right here. Okay, they're giving me probability of A, and we need to figure out this guy, probability of A and B. That's what they're asking about. They want to know, let's see, what is the probability that he makes both goals, right? That means they're asking for find probability that both will occur at the same time. Okay. So as long as we have everything except all quantities except one in an equation, we can solve for that missing quantity. So we've got all the information we need. So let's write down our data. Probability of B given A is 0.80. They're giving it to us right here. Okay. Probability of A. So this is, we don't know probability of A and B, so we'll give it a variable name. We'll call it X. Probability of A, did they give us that? And they're saying probability of A is also 0.80. Okay, so we just have to solve the equation 0.80 equals x divided by 0.80. So how do we solve that? Let me write it a little bit more kind of naturally. 0.8 or 0.80 is equal to x over 0.80. How would I solve that? Well, I have to get the 0.80 out of the denominator. How do I do that? We're going to just multiply, right? Multiply by 0.80 on both sides. Okay, and we cancel here. And of course, we end up with what? We end up with our result. What's our result? That x is equal to 0.80 times 0.80, which is 0.64, okay, or 64%. Okay, but they want the answer in decimal form, so they want the answer this way. Okay, if they said what percent, it would be the percent version. All right. Okay, good. Okay, so this is problem number 4. Now, as soon as I see the word given that, I know we've got a conditional probability, right? So let's think about which way to write the conditional probability. Do I want to write it that the events are called A and B? So do I want to write it as probability of A given B? Or do I want to write things as probability of B given A? Depends on what they're asking for, what they're giving us. Okay? They're giving us the probability that he makes his second goal given that he made his first goal. So remember what we said before. Whatever is after the word given that is after the conditional bar. So this is, so the making the first goal is after the conditioning bar. Okay, what's the conditioning bar? It's that little bar, the little vertical bar. So first goal is A. Okay, first goal is A. So that means they want this guy, or not that they want it, they're giving us information about this guy. All right. Now the first one is interesting, but we're not going to use it in this problem necessarily. They're giving us information about B given A because they're saying given that he made the first goal. So what is probability of B given A? They're telling us it is 0.75. Okay, make that a little prettier. Whoop, not doing a very good job of that, but anyway, you get the idea, 0.75. Okay, so that's one fact that they're giving us. What other facts are they giving us? They're giving us the individual probabilities, right? They're saying P of A by itself is 0.75. Probability of B by itself is 0.65. Okay, now what are they asking us for? They're asking us for the or. Okay, or means one or the other or both. So first goal or second goal or both. That just means the both comes along with the ride. When you do A or B, both if both occur, that satisfies the A or B criteria, right? Like if you have, let's say you say today I'm going to eat either breakfast or I'm going to eat lunch. If you eat both, then that still works, right? It still satisfies the criteria for the or. So or means one event or the other means, or both also satisfies that situation. So when they say first goal or second goal or both, don't worry about the or both. That comes along with the territory of first or second. Okay, so they want to know, so the question is, find probability of A or B. Okay, or both comes along with that. You don't even have to think about or both because it's part of A or B. Okay, now, next issue is, what equation do I know about an or? Okay, and we know the or is the addition rule. Okay, probability of one event or the other is equal to what? Probability the first occurs plus probability the second occurs. But if both events occur at the same time, then that would get counted as part of, like if A and B are occurring at the same time, that would get counted as part of A and it'll also get counted as part of B. So that's double counting. So we have to subtract the probability that they both occur at the same time. Okay, that gets subtracted off. Now, that's our basic equation for or. Now, which pieces do we have? Do we have P of A? Yes, they told it to us, right? 0.75. Do we have P of B? And the answer is 0.65. They told it to us. Do we have probability of A and B? And the answer is no, not directly, but we can build it. How do we build it? We build it the way we built it in the last problem. Okay, we can use the conditional probability to figure out the probability of both occurring. How do we do that? Well, what's the conditional probability formula? The conditional probability formula is, so we're going to utilize this information here. The conditional probability formula says that the probability of B given A is equal to what? The probability that both occur at the same time divided by the probability that the event after the conditioning bar occurs. This is the conditioning event. We're going to assume that's happened. So we divide by the probability that that conditioning event has occurred. Okay? If I have this part and this part, I can get the B and A. You can always get, as long as you know the probability of the conditioning event, you can get the probability of the, and you know the conditional. If I know the conditional probability and the probability of the conditioning event, the event after the conditioning bar, if I know those both, I can get the probability of the intersection, both occurring at the same time. Okay, so what is the probability of B given A? Well, they told it to us, right? This is 0.75. Okay, so I've got 0.75 on this guy. How about over here? Do I know P of A? Yes, P of A is also 0.75. Okay, so I know the 0.75. I know B given A, and I know A. So how do I figure out the probability of both occurring at the same time? Well, we'll call it X, and we can solve that. So let me kind of draw a little bar here so we don't get confused. Okay, so, whoops, hello. Okay, so this is my little extra work down here. Okay, so how do I solve this? How do I find X? Okay, I can rewrite this equation as 0.75 is equal to X over 0.75. How do I solve for X? Multiply both sides by 0.75, right? So if I kind of sneak in an extra 0.75 in here, multiply by 0.75. Whoops, can't write at this end of the screen with this software. Sorry about that. But anyway, I'm going to sneak in an extra 0.75 on both sides. I'm going to say 0.75 times the left side is equal to the 0.75 times the right side, because that cancels the denominator, gives me X. Okay, so X is going to be 0.75 times 0.75. And what is X? X represents the A and B, right? X that I'm solving for is the A and B. So we're using the type of analysis we did in problem 3, we're using it now for problem 4 to figure out this one component that we need in problem 4. All right? So we remember, both of these equations are going to be important. The conditional probability formula and then the probability of the so-called addition formula, this probability of one event or the other. Okay, and we can use them kind of hand in hand. And that's it. Okay, so for problem, looks like number 5 here. Probability that you roll a 3 given that the number you rolled is odd. So this is a given that. Given that means conditional probability. So they're not naming these events, so let's kind of, put some names on them. So number that you rolled is odd, let's call that event B. Okay, and roll a 3, let's call that event A. So they want us to find, given this notation, they want us to find probability of A, which is that you roll a 3, given that you've rolled an odd number on the dice. Okay, and we know the formula for that, right? Probability of A given B is equal to the probability that both occur at the same time divided by the probability that the event after the conditioning bar has occurred. And the one after the conditioning bar is the one that says given that, which means odd. Probability that you rolled an odd, which is probability of B in this case. Okay? Now, do we know, again, in this case, they want us to find A given B, which means we better know both of these guys. Okay? So let's write out what's called the sample space for rolling a single die. So the sample space for one die, whoops, not a pair, just one die, is going to be this. You roll a 1, a 2, a 3, a 4, a 5, or a 6. There's your sample space. That's all you can roll on a single die, right? Okay, so do I know the probability of B? What's B? Odd. Okay, so the probability of rolling an odd is going to be, you can roll a 1, a 3, or a 5. So the probability of odd is going to be what? 3 ways it can happen out of 6. Or 0.5. Okay, so I know this guy. This guy is 0.5. Okay, probably of getting an odd. Now, what about rolling an odd and a 3? Well, let's think about how you can have an odd and a 3. Which numbers on the die are both odd and a 3? And the answer is there's only one way that can happen. This guy. The only way to get an odd and a 3 is to roll a 3. There's no other numbers on here that are both odd and 3 at the same time. So the probability of odd and 3 is going to be one way it can happen out of 6. There's one event that gives me, there's one outcome that gives me the event odd and 3, and there's 6 possible outcomes total. So there's one outcome out of 6, okay, or 1/6. Okay, so this guy is 1/6. Okay, so we can go ahead and compute this, right? So what is the probability of A and B? So probability of A and B is going to be 1/6 times 1/2. Actually, I'm sorry, 1/6 divided by 1/2. Okay. Now, how do we divide a fraction by a fraction? So remember, it's not multiplication, it's division with conditional probability. So how do we divide a fraction by a fraction? You multiply by the reciprocal. Right, just take this guy and flip it over. Right, there's the flip over, see it? Okay, and so we get what? 2/6 or 1/3. Okay, so, or in decimal form, I think they want decimals here, it'd be 0.333. Okay, answer to 3 decimal places, yep. Okay, so now, is there another way to do this? The answer is, if you have a listing of everything in the sample space, then you can typically get the probability you can get a conditional probability directly if you have a full listing of the sample space. So if I just rewrite the sample space, my sample space is this, right? 1, 2, 3, 4, 5, 6. Now let's say that I roll, the way we do this directly, the direct method, just by counting elements in the sample space, the so-called direct method, will work in simple cases where you have a full listing of the sample space. We have a full listing, my pen's not working correctly, of all elements in the sample space, all outcomes in the sample space. Sometimes we don't have that. Okay, when we do, we can use the direct method. And we have a full listing. Okay, this is my initial sample space. Initially, when you roll a die, that's your sample space. Okay, now, what if I roll an odd? If I roll an odd roll, that means I'm reducing the sample space. So now we're going to say we roll an odd number on the die. So now my new sample space is 1, 3, 5. This is called a reduced sample space. The way we created a reduced sample space is we assume that the initial event has occurred, and that's going to wipe out certain initial sample space elements. The 2, the 4, and the 6 are no longer possible because we know we've rolled an odd number. Okay, now what I can then do is I answer the question. So instead of saying roll a 3, given that the number I rolled is odd, I'm just going to say what's the probability of rolling a 3 using the reduced sample space. Okay, because given that the number rolled is odd, reduces the sample space. Okay, so this reduces the sample space. Reduces the sample space. Sorry about that. Writing a little sloppy here. Okay, so I'm reducing the sample space to 1, 3, 5. In this reduced sample space, what's the chance of getting a 3? And the answer is obviously what? The answer is there's one way to do it. Okay, so the probability of rolling a 3, or probability of event A, which is rolling a 3, in the reduced sample space, is going to be one way the outcome occurs divided by 3 outcomes total, 1/3. Okay, so you can use the conditioning event, the event that's the given that's called the conditioning event. You can use it in the formulas to divide. You divide this is called the joint probability. Probability of both occurring at the same time. You can take the joint probability divided by the conditioning event probability. You can use the conditioning event that way in the formula version of answering the question, or you can use the direct method. Direct method would be use the conditioning event as a way of reducing the sample space and making a smaller sample space, and then you can directly compute the probability within that smaller sample space. Okay? Both should give you the same result. When can you use this direct method? When you have a full listing of all outcomes in the sample space. And it's not too crazy of a listing. Okay? If you have like thousands of things in it, then you might just want to use the formula method instead. Okay? All right, cool. Okay, so let's actually skip ahead to problem number 7. Sorry about that. Okay, and now in problem 7, let's name, they're not giving us abbreviations for these events, so let's kind of just name them a little bit. So we'll say that, well, we'll stick with this color. You've got a 90% chance of being accepted. So accepted, we'll call this event A. And the other event is getting a dorm. Okay, so for the dorm, we'll call this event B, getting a dorm. Now, they're asking us about and. So what equation do we know about and? Well, I know, so they want us to find probability of A and B, both occurring at the same time. You get accepted and you get a dorm. Okay, A is accepted, B is a dorm. Now, what equations do I know that involve A and B? Well, I know the or, right? That's the addition rule. I know probability of one event or the other is equal to the probability of the first plus the probability of the second minus the probability of both occurring at the same time. So if I know, so let's think about this. If I know if I know these three components, these three values, I can figure out the fourth value. So let's see if I know them. Do I know the probability of A? Do I know the probability of being accepted? Yes, I do. Do I know the probability of B? Well, it looks like I kind of do, right? 45% maybe, but we'd have to think about that. Is that really what they're saying there? Because really this is the probability of getting a dormitory. It's not 45% of all students, it's 45% of all accepted students. So maybe we kind of know B. I'm not quite sure about getting a dorm. But do we know the or? We don't know this. Okay, they didn't tell it to us. Because they didn't tell it to us, that means I don't have enough information to use this equation. All right, so what other equations do I know that involve A and B? Because that's what they're asking us about. Okay, and the other equation I know is the conditional probability. I know probability of A given B is what? Probability of the two occurring at the same time divided by the probability of the event after the conditioning bar. So as long as I have all of these, I can get, as long as I have the A given B and the B, I can get the A and B. Now, do I have these? Well, first of all, what is B? Probability of B is getting a dorm. Okay, A given B would mean this would be the probability of A. What's A? A is being accepted. So this would be the probability of being accepted given what? Given that you get a dorm, because B is a dorm. You get a dorm room. Okay, is that what they're giving us? Probability of being accepted, given that you get a dorm room? No, they're giving us the probability of what? The probability of getting a dorm. The 45% is the probability that you get a dorm given that. When they say of all, that means given that. Given that you're an accepted student. Okay, so if you're an accepted student, there's a 45% chance you'll get a dorm. Okay, so they're giving us probability of B given A. So given that A has occurred, that you're accepted. So let's write the equation that way. Okay, so I know probability of B given A. Can we use that? Because that's going to be the probability of what? Probability of B, which is getting a dorm, given that you're accepted. Okay, so that's what B given A is expressing, probability of getting a dorm, which is B, given that you've been accepted. That is information that we have, right? Now, what would that equal in terms of an equation? That's the probability of both events occurring at the same time, divided by the probability of the event after the conditioning bar. What's the event after the conditioning bar? A. What's A? Being accepted. Okay, so on this one, I'll leave the rest to you. Okay, so I would use this equation, and we can use this equation, and we can use it to figure out the probability of A and B. Okay, I'm just sort of helping you sort of like sift through the various equations to see which one to use. All right, but I'll leave the rest to you because you have to be able to do it on your own on the test if this was a problem on the test. Okay, all right, cool.